Welcome to Math 2210, where we'll be working some problems from Chapter 6, which has to do with the normal distribution. First question. Suppose that x is normally distributed with a mean of 10 and a standard deviation of 3. What is the z-score of x equals 8, and interpret this score? Perhaps just a quick review of what we're talking about here. We're normally distributed, so we have this familiar bell-shaped curve, which you probably have seen before. Now, it's bell-shaped, but it may be wide or it may be narrow. The mean is always the value in the middle, which in this case is 10, and the standard deviation indicates the spread of this. So the larger the standard deviation, the wider this bell shape will be. So, based on what we have, what's the z-score of x equals 8? Well, the formula for z is x minus mu, our mean, over sigma, our standard deviation. So let's plug in the information that is known to us. We're saying suppose x is 8, so that would be like right here in the picture. So it's 8 minus 10 over 3. The 10 and the 3 are given in the statement at the top of the page. Well, this would equal negative 2 over 3. If we convert to a decimal, it would be negative 0.6. And what it's going to be is just a repeating 6. 2/3 is negative 0.6666, so on. Now, if I round to 2 places, then it would be 0.67. As far as rounding goes, just whatever's asked on a homework problem or the test, just go with that. You know, if I say 2 places, this is what you do. Take it out further if I say 4 places. So that is the z-score. Now, what's it mean? Well, if you look at the picture, you see that 8 is to the left of the mean 10. When it's to the left, you'll always get a negative z-score. If it had been to the right, you would have gotten a positive z-score. So we would say here that 8 is 0.67 standard deviations to the left of the mean. We don't say it's negative 0.67. The negative is indicated by the word left in the statement. So if our answer were, let's say the z-score was 0.8, then we would say we were 0.8 standard deviations, and since it was positive, we'd say to the right of the mean. Okay. Slightly different wording. We got the same original statement. We're saying what x value has a z-score of 0.5. So let's write down the formula again for a z-score. Z is x minus mu over sigma. Any of this stuff, that you'll likely be using on a test, start adding it to the formula sheet that I allow on tests. All right, let's plug in what we know. We're saying that the z itself should be 0.5. We don't know the x. That's still a variable. We plug in the 10 and the 3 that are known. And now this just turns into a problem in algebra. Let's first clear the fraction by multiplying the right and the left-hand side by the 3. If you multiply the left-hand side by 3, 0.5 times 3 will be 1.5. If you multiply the right-hand side by 3, it just cancels out the fraction and leaves you with the x minus 10. We could now add 10 to both sides to solve the problem, and we would get 11.5. So 11.5 would have a z-score of 0.5. Notice, kind of comparing this to what we did in problem A, 11.5 would be to the right of 10, wouldn't it? So it does make sense that it should have a positive z-score. All right, now let's see. Next problem. Suppose that the height of Wookiees follows a normal distribution with a mean of 2.1 meters and a standard deviation of 0.2 meters. Find the probability that the height of a randomly chosen Wookiee, like Chewbacca, is greater than 2.2 meters. Draw a picture here. So we know it's a bell-shaped curve. We don't really know how wide to draw it, okay? We know that the middle, that is the mean, is 2.1 meters. And we want the probability that our randomly chosen Wookiee will be greater than 2.2. Now notice 2.2 would be to the right of 2.1. I'm just drawing it far enough to the right that it's easy to distinguish, but maybe it should be drawn closer. Now, here's what we do. We draw a line up to the curve there. Now, unlike the uniform distribution, which gave us a nice rectangle, we don't get a nice rectangle here. It's the area under the curve, but it's going to be kind of complicated to calculate that area. Now, let's see, what side do I shade? Greater than 2.2, so I'm shading to the right here. The thing is, this extends out to infinity, even though, of course, the value there is pretty small as you go on out to the right. So our answer will be the area of this. So there's no easy formula you can do like base times height. In fact, it takes fairly elaborate calculations in calculus to come up with this area. You won't have to do that. Fortunately, your calculator has been programmed to find these areas. And the area will equal the probability that we want. So the probability that x is greater than 2.2 will be that area. Let me switch to my calculator screen in order to show you how that's done. Unfortunately, there's not a real convenient way for me to make that switch. So here we are. Keep in mind the values that we have. We're going to do second distribution. Pull up our distribution here. You will never be doing number 1, normal PDF. You will always be doing 2 or 3. You'll be doing normal cumulative distribution function to find an area. So okay, fine. Let's go and select number 2. Now it gives a lower and an upper. On our picture, the lower will be the value on the left, the upper will be the value on the right. Well, again, hopefully you drew that picture. Our left-hand value was 2.2. Now, what about our right-hand value? Well, technically our right-hand value could go out to infinity. I mean, not that we'd really expect a Wookiee to be 100 meters tall, but distribution-wise, it could go on out to infinity. The easiest way to do that is to use scientific notation. I'm going to write 10 to the 99th power, which is not an infinite, but of course it's ridiculously large. And the way you do that using this calculator, you want this little EE button. So you do second to get the EE, and now you can type in 99, and that's shorthand for 10 to the 99th power. And now all we have to do is put in the mean and the standard deviation I gave. The mean of the Wookiees, I said, was 2.1 meters, and the standard deviation was 0.2 meters. Now, depending on the model calculator you have, you might be able to hit enter right now to get your answer. With this one I'm doing, you have an extra step. You have to paste. So I go down to highlight paste, I do enter. It pulls it up in my main calculator screen, and now I click enter to get the answer. So that might not be necessary for you to do that. Let's give the probability to 4 places, which seems to be what the homework's been doing, and that would be 0.3085. So I'll go back now to my PowerPoint, and we'll continue. But it was 0.3085. Okay, so that's how you find a probability using your calculator. Next question. Let's find the middle 60% of heights. The middle 60% of heights falls between what two values? So let's find those values. Let's draw our picture here. Bell-shaped curve with the mean here, the middle. It's the mean and it's also the median. It's a value right in the middle. Sorry, it's mean of 2.1. And so we're looking for what middle heights would have an area of 0.60. So, you know, my picture's not perfectly symmetrical, but I'm thinking of this being symmetrical, okay? The same distance on the right and the left where 60% of the area would fall in there. And I want to know what A and what B is. You know, for instance, A might be 2 meters and B might be 2.2 meters, you know, something like that. But we'll do it correctly and we'll get the exact value. Now, this is a problem where we're not finding a probability. Notice we have the probability, 60%. When we have the probability and we're trying to find the value at which that occurs, essentially what we're doing is we're finding a percentile. And on the calculator, it will be that third button, which is inverse norm. I'll show you how you do that. To logically get the value A, okay, to get that from the picture, we need to know the probability that x is less than A equals, now what percentage would be to the left of A? If you're thinking 40%, you'd be wrong about that. We have 60 in the middle. Notice that means 20% would be in the left tail and 20% would be in the right tail in order to give 100. And it's symmetrical, so we know that they're both the same. So technically, we want to find the 20th percentile to get the value of A. 20% of the area will be to the left of that. Now, it will just be a calculator problem, so let's go through that. I'm glad I have this calculator screen I can show you. So, we will go to get the distribution again by doing second and then clicking that button. There we go. Want you to go down to 3. So you'll always do 3 inverse norm to find percentiles. Let's enter that. So the area will be that area on the left. For a percentile, it's always the area to the left. So it is 0.2. Let's see. Our mean is the 2.1. I'm just using my computer screen to type these in rather than you all know how to do it over here on the left. And for the standard deviation, I have the 0.2. All right, so let's just go down and let's go and enter that in. And we have 1.93. Notice that's not a probability. That's a value on the x-axis. So when we come back here to our screen, this value A is to 2 decimal places 1.93. Now let's get the value of B. To get the value of B, again, it'll be a simple calculator problem. We want the probability that x is less than B. Now what probability do we want? Well, what percentage will fall to the left of B here on your picture? Well, both the 0.6 and the 0.2, right? 80% falls to the left of it. So this is an 80th percentile, which we can, again, go and easily find with our calculator. So for this one, again, second distribution. Go down and get the third one and enter that. And the only difference is I will change this area to be 0.8. The other values are still the same. Go and paste it and enter it. And that's what we got. To 2 places would be 2.27. So 2.27. By the way, you could also check and see that 2.1 falls right in the middle of these two values. The normal curve is symmetric, so that should be the case. Now I have one last problem that I'm going to do with you here. Let's see. I think it should be an easy one for you if you followed the last problem. Find the minimum height needed for a Wookiee to be in the top 2% of all Wookiees in terms of height. Now, got this. Okay, that's a terrible picture there. Use your imagination. We want to be in the top 2%. In other words, we want this area to the right here to be 0.02. So what percentile is that? Okay, to get this value A. Well, the probability that x is less than A wouldn't be 0.02, it would be 0.98. If you're in the top 2%, you're at the 98th percentile. And I won't bother going to the calculator this time because I already showed you how to do that inverse norm. I recommend you do it on your own to make sure you're in good shape with this. A will turn out to be 2.51. That would be in terms of meters, so only 2% of the Wookiee population would be 2.51 meters or higher. Okay, that ends this lesson. Good luck to all of you.